Hello. Today we'll be talking about the atom structure, what makes an atom unique, the periodic table, and how to use it. Here's the periodic table. Here. It's got a lot of atoms. I'm going to guess. There's 110, I think. That might just be an empty square. So, let's start with the periodic table. How we use it. As you can see, there are numbers up here and right here. These are different columns. On each column here, numbers which column you're looking at. These kind of fit in up here, I guess. It's where we have that. Anyways, also, another thing that this list going across this way does is it tells you how many energy levels it has. These lists going this direction, however, tell you how many valence electrons it has. Valence electrons are different types of electrons. You can just leave it at that. I think works good that way. I just call them unique. That's what you can call them. In this row, we have 1, 2, 3, 4, so on until we get to here. Here, skip. Here we start again. We start 13, 14, 15, 16, 17, 18. But there aren't that many electrons. Instead, there are 3, 4, 5, 6, 7, 8. Here, each level allows you to add this direction of energy level, allows you to add more valence electrons. As you can see, you do not add more unless you get lower. This up here, such as helium for example, helium only has 2 valence electrons because, although it is in row 18 and should have 8 supposedly, it is only in row 1 and has a limit of 3 or 2. In this case, helium has 2. It only has 2 electrons, so, of course, it would only have 2 valence electrons. Some atoms don't have only valence electrons. Some have normal electrons, or just electrons. Electrons can be determined by this number. This number right here is its atomic number. Its atomic number also tells you how many protons it has, which determines what type of atom it is. In this case, silicon. This is its name at the bottom. Atomic mass is right under the symbol SI. Symbol doesn't always match what it is called. Such as gold. Gold has a symbol of AU. Here, however, it's different. How many electrons it has is determined by this atomic number, because protons have a positive charge, P, whereas electrons have a negative charge, N. And, as in all magnets, negatives and positives attract each other, or in this case, it would be more like this. So, to balance that out, you would have to have 14 protons and 14 electrons for it to be balanced and not uneven. All of this, however, takes place in the nucleus of an atom. In the nucleus are protons and neutrons. Neutrons have no charge positive or negative. They have a neutral charge, or no electrical charge, so ignore that up there. In the nucleus, it's just a little ball here, and then you have this electron cloud around it. Ignore these things. In the electron cloud are, of course, electrons. Neutrons and protons all have 1 AMU, or atomic mass unit. though electrons are too small to be counted. They're approximately like 1,188 times smaller, somewhere around there. So, let's go to this next page. In an atom, we have an atom here. There's the electron cloud. That is probably really close to what it is in comparison. If you have an inch for the nucleus, the electron cloud supposedly is approximately 1 mile long. That's how big the electron cloud is per nucleus. So, here, the nucleus, or here, you have... So, on the other page we saw the silicon, and it said, here. Here, though, 1 second please, we have this number here, the atomic mass. As you can see, we have 14 protons, but we have 28 point something, which we don't count this, we usually round it. We have 28. How does this work? Well, there are neutrons, N. Neutrons are in the nucleus along with the protons. So, where was I? Here, let me erase this real quick. Dun. Let me see if I can get rid of this. There we go. So, on here, let's move this up here. We have... Here, let me point it out real quick. So the atomic number and the atomic mass don't match. So let me draw a nucleus here. In the nucleus we have all these little dots. Some of them have a positive charge, some of them have no charge. The positive is the proton. The other, no charge, is the neutron. Now, to balance out the weight, we have 14 protons. Let's just count that as 14. And so, in turn, we have 14 neutrons to equal 28. And, hold on. With 28, that is our weight. Now, with all of them, we don't always have the same equality between protons and neutrons. But, of course, that's not how nature works. Not everything is equal. Let's just leave it at that. So, next, we'll talk about what makes an atom unique. Let me move this out of the picture. An atom is unique because the number of protons determines what type of atom it is. So, as we saw in silicon, we had 14. If it has 14 protons, it equals silicon. Now, back to this. I believe that covers just about it. Here's this as an example. We have the atomic number, symbol, atomic mass, name, once again. And that about wraps it up. And that's the end of this.